Hi everyone, thanks for watching. In this video, I'll introduce balanced chemical equations and explain why they're important. Remember from some previous videos that we've seen two ways to represent chemical changes so far. One of them, called a particle model, shows every individual atom, the proper amount of each atom, and how they're attached before and after. This is really accurate but takes a long time. In the last set of videos, we saw there's chemical equations which use formulas, so it's a lot faster, but it's less accurate for a couple reasons. This video is going to ask the question, how could we use the speed of the chemical equation but make it more accurate? So let's start off by taking a look at one of the things that makes equations inaccurate in the first place. A good example of this is Mg plus O2 turns into MgO. If you look at the more accurate particle model version of this, you might notice immediately that something's wrong here. On the reactant side, I start with 2 oxygen atoms, but on the product side, I've only got 1. The amounts of oxygen atoms don't match. In fact, it seems like one of these oxygen atoms has completely disappeared or gone away. This is impossible according to a law called the law of conservation of mass. This law says that in an isolated system, mass cannot be created or destroyed. So this oxygen atom that I lost, it's kind of impossible to destroy or lose that atom. So let's talk about some ways we could write this chemical equation that fixes the mass conservation problem. We're going to do this first by talking about ways that you can't fix it. One thing that people try to do a lot is fix the problem by adding in subscripts. Like, what if MgO's formula was MgO2? That would take care of it because there's 2 oxygens on the left and now there's 2 oxygens on the right. The only problem is MgO is an ionic compound with a very specific formula. Mg is a +2, oxygen's a -2. They balance with just 1 atom apiece. You can't add in a second one. Another thing you can't do is take subscripts away. If it was just Mg plus O, then it would work because there's 1 oxygen on each side, but O2 is a covalently bonded molecule and it exists in nature as O2, so you have to write it that way. Take a moment to note the things that you can't do to fix this problem. Now let's talk about what you can do. So let's make a little room and take a look at exactly how these atoms rearrange. The real issue here is that this reaction is impossible with just 1 magnesium and 1 O2. Imagine an oxygen sort of breaking free from O2 and bonding to the magnesium. This works great to make 1 magnesium oxide, our product, but the problem is we have this leftover oxygen that has nowhere to go. You could imagine a different scenario where you've got the O2, but this time 2 separate magnesium atoms. Now, an oxygen atom has a place to go. We've made the product MgO. My second oxygen atom also now has a place to go to make a second MgO. We're still making the same product. We're just making 2 of them. So now let's apply these quantities to our particle model. Remember, 1 magnesium atom isn't enough. It's going to take 2 of those, so we could draw in a second. On the equation version, to make that more accurate, you could do the same thing by simply writing the Mg symbol twice. Now you're representing that it took 2 of those atoms. In the products, this produced 2 separate MgOs, so we could do the same thing in our equation, just write the formula for MgO 2 times. This is exactly what you are allowed to do to fix the conservation problem by adding multiple reactants and multiple products. The only other step we can take to make our lives even easier is to stop from writing this same symbol twice. We can just write Mg once, but put a big 2 out in front to show that we used 2 of those. Also for MgO, instead of writing that formula twice, just write it once with a big 2 out in front to show that we produced 2 of those. Finally, we see our first balanced chemical equation where the amounts of atoms in the reactants are the same as the amounts of atoms in the products. There's 2 magnesiums on both sides and 2 oxygens on both sides. So when you're writing balanced chemical equations, this is your goal. You want to balance it by adding these numbers in front of the formulas called coefficients. Those coefficients are added in front when multiple reactants or multiple products are needed to give us the same amount of atoms on each side. That concludes this video. Here's a brief summary.